Hello everyone, this is Dr. Amina, Assistant Professor in Physics. So today's session is 26. We shall we shall see here the third law of thermodynamics. So what is third law of thermodynamics? Why it is impossible to achieve a temperature of 0 Kelvin? Then we shall see entropy, order, disorder, and entropy. So recap on the introduction of thermodynamics. So we have the basics of thermodynamics, properties of the materials, solids, and its order, and second law of thermodynamics. So the learning objective is to understand how orderness changes with respect to the temperature to describe what information that achieve a temperature of 0 degree Kelvin. This session outcome will give the information about third law of thermodynamics and why to achieve a temperature of 0 degree Kelvin, and also how entropy changes with respect to temperature. Now, what does the third law of thermodynamics mean? The third law of thermodynamics states that the entropy of a perfect crystal at a temperature 0 degree Kelvin is equal to 0, and the entropy denoted by S is a measure of the disorder or randomness in a closed system. It is directly related to the number of microstates, a fixed microscopic state that can be occupied by a system, accessible by the system. That the greater the number of microstates, the closer the system can occupy, the greater its entropy. The microstate in which the energy of the system is at minimum is called the ground state of the system. And then we have the third law of thermodynamics. At a lower temperature, at a temperature of 0 degree Kelvin, the following phenomenon can be observed in a closed system. The system does not contain any heat. All the atoms and molecules in the system are at their lowest energy points. Therefore, a system at absolute zero has only one accessible microstate, its ground state. As per the third law of thermodynamics, the entropy of such a system is exactly zero. Now, why it is impossible to achieve a temperature of 0 degree Kelvin? For an isentropic process, the temperature reduces for such substances by modifying the parameters x1 and x2 to an infinite number of steps must be observed to order to cool the substance. This is because the third law of thermodynamics states that the entropy changes at its absolute zero temperature is zero. Therefore, the entropy versus temperature graph for any process attempting to cool a substance to absolute zero is illustrated below. Now we can have the graph here. It can be observed that the lower the temperature associated with the substance, the greater the number of steps required to cool the substance. As the temperature approaches 0 degree Kelvin, the number of steps required to cool the substance further approach the infinity. So we can see the graph S versus T here with the values x1 and x2. Now third law of the laws of thermodynamics states that delta U is equal to Q minus W, where delta U is the internal energy and the Q is the amount of heat absorbed and W is the amount of work done. So a continuous system which is not consuming internal energy cannot output more work than it takes in the heat energy. Then the maximum efficiency of a heat engine is calculated by using 1 minus Tc divided by Th, or you can take 1 minus T2 divided by T1. So now T2 Tc is equal to 0 is not achievable. So the entropy. So a reversible engine has the following relation between the heat transport and the reservoir temperatures. So we can take Qc divided by Qh is equal to Tc divided by Th. Now this quantity Q by T is the same for both reservoirs. The conserved quantity is defined as the change in entropy. Now the entropy of a system can be defined as the ratio of heat to the temperature. Like internal energy, entropy is a state function, and unlike energy, entropy is not conserved. In a reversible heat engine, the entropy does not change. So the entropy of a real engine will operate at a lower efficiency than a reversible engine. This means that let heat is converted to work law. This is also one of the theorem of Carnot heat engine. So any reversible process results in an increase of entropy. So we can see the equation 1 minus Qc divided by Qh is less than 1, which is again minus Tc divided by Th. If Qc divided by Tc is greater than Qh divided by Th, the total entropy can be written as Qh divided by Th plus Qc divided by Tc for irreversible process. This is an example for a reversible engine operating between the temperatures 550 and 300 kelvins with the total work done 1200 joules of the heat. So we can calculate delta S total is equal to Qc divided by Tc minus Qh divided by Th. So we can calculate the total entropy of the system. Now to generalize, the total entropy of the universe increases whenever an irreversible process occurs. The total entropy of the universe is unchanged whenever a reversible process occurs. Since all real processes are irreversible processes, the entropy of a universe continuously increases. If entropy decreases in a system due to work being done on it, the greater increase in entropy occurs outside the system. So we have the graph here for the order disorder of the entropy. Entropy can be thought of as the increasing disorder of the universe. In this diagram, the end state is less ordered. You can see that the end state is less ordered than the initial state. So the separation between the low and high temperatures area has been lost. So we can see high temperature, low temperature, heat flow, and intermediate temperature. Now, as the total entropy of the universe increases, its ability to work also decreases. The excess heat exhausted during an irreversible process cannot be recovered into a more organized form of energy or temperature difference. Doing that would require a net decrease in entropy, which is not possible. Now, the summary of this session is a continuous system which is not consuming internal energy cannot output more work than it takes in heat energy. Entropy can be thought of as the increasing disorder in the universe, whereas the entropy of a perfect crystal as a temperature of a of 0 Kelvin is equal to 0. So now we have the numerical multiple choice questions. We have these 5 multiple choice questions are given. So thank you for this.